Hi guys, so we're going to try to keep this short. Our target today is just graphing and solving compound inequalities. So what is a compound inequality? It's where an inequality is formed by joining two inequalities with the word or, and. So if you look here at our example, it tells us the graph of a compound inequality with and is the intersection of the two inequalities. So that means that everything that's represented by our final graph is a solution for the first one and the second one. So if you look, we have x is greater than or equal to 2, our filled in dot. Since it's greater than, it's going to the right. X is less than 5 is our open dot, and it's less than, so it's going to the left. So now we have this and to think about. So that means that we still start at 2 and 5. So we keep that closed dot at 2, keep that open dot at 5. And because we know that 2 goes to the right, and for the 5, x goes to the left. So the things that's included here and shaded in is just what's intersecting. Okay. So now for or, this means that it is the union of both graphs, which just means that you're going to graph both equations. So we have y is less than or equal to, we have a filled in dot, we have y is greater than 1, which gives us our open dot, and we know that they're going in those opposite directions. So because it says or, we're going to graph both lines. So this one's nothing special. You just graph both in the same line because y can be either. So for and, it has to be the intersection. For or, it can be whatever the graphs are. Alright, so we're going to practice these. So we have x is less than 4 or x is greater than 5. What did this tell us? We're going to just graph them both on the same line. Okay, so here is 4. Here is 4. Here is 5. Okay, so they're both less than and the other one's greater than, so they are open dots, no closed dots here. Okay, for x is less than 4, that means it's going to the left. For x is greater than 5, that means it's going to the right. And we're done. Let's do one more or. So we have 3. Oh. We have 3 and negative 2. So I'm going to put my 0 here, my 3 over here, my negative 2 right here. So negative 2 is greater than or equal to. That is a filled in dot. Okay, if x is greater than or equal to, it's going towards the bigger numbers to the right. This one, x is greater than negative 2. So this is an open dot. And this is also going towards the right. So now we have x is less than or equal to 4, and x is greater than negative 3. So I'm going to write these over here. We have our first one, x is less than or equal to 4. I'm going to graph this. So we have our 0 here and our 4 over here. It's a filled in dot. And it's going to the left. Now we have x is greater than negative 3. We have our 0, we have negative 3. So now we're going to have that open dot, and since x is greater than, it's going this way. So now we have to look at what they have in common. So we're going to go all the way to -3 to 4, and to -3 to 4. So it looks like what they have in common is, here's our 0, here's our -3, here's our 4. There's an open dot at -3, a closed dot at 4, and then the arrows are going towards each other, so it's everything in between. And that's our graph. So now we're going to go down here. I'm going to draw the other ones below it. 0, 0. Okay, x is greater than or equal to 3. So here's 3. It says equal to, has that line, so we're going to do filled in dot, and if x is greater than, we're going to the right. Okay, this one says x is less than 1 or equal to 1. So it is another filled in dot. And if x is less than, it's going to the left. And here's the trick, because it has to be an and. It has to be a solution from both. We know that there's no number greater than 3 or equal to 3 that is also less than or equal to 1. So what are we going to do for this one? Well, since the statement is not true, there's no number that satisfies both. We're going to use that phrase that we know very well now, no solution. Alright, you guys are going to practice the next two. So make sure you pay attention to this and, this or. Yes. Scroll down to example 2. We're going to solve these. So how are we going to solve these? Well, we're going to solve them like a normal equation. And you can first split them up. So x is less, -4 is less than x minus 2. Then all we're doing is adding our 2. We get -2 is less than x. Now for our right side, we have x minus 2 is less than 3. We're going to add 2 and get x is less than 5. So now we're graphing. I'm going to do this a little differently. I'm going to graph one line. So if this is -2. -2 is less than x, and that means x has to be greater than -2. So we're going to have an open dot, and we're going to go to the right. Now in blue, we're going to go to, here's 0, here's 5. X is less than 5, so that's an open dot. We're going to the left. Okay, so what do they have in common? You have an open dot at 2, an open dot at 5, and all of this middle red space is our graph. So now we're going to do B. We're going to do it a little bit differently. So how we can solve this is by taking our same steps but doing it to both sides at the same time. So now we have -4 is less than -2x, which is less than or equal to 8. Okay, so now we're just going to divide by -2 on each side. We're going to get 2 in the middle x, on the right -4, Now what's special? We're dividing by negatives, so we're flipping those signs. Greater than, or equal to. Okay, so now we're going to graph. Here's my 0, here is 2, here is -4. Okay, we have a, oh, sorry about that. We have 2 is greater than x, so that is an open dot. If 2 is greater than x, then x has to be less than, so that's going to the left. And then we have -4 is less than or equal to x, so that's a filled in dot. Okay, if 2 is greater than x, then x has to be to the left of 2. And if x is greater than or equal to -4, it has to be to the right. So our line is right here in the middle. Okay, so now we're solving with OR. So we have to solve these separately, but we know how to solve these. We add 5. We're left with 3y is less than -3. We divide by 3. Do we switch the sign this time? Nope, because it is positive. So we have y is less than -1. Now we're on to our second. 2y minus 1 is greater than 5. We're going to add 1. We're left with 2y is greater than 6. Dividing by 2. Do we flip the sign here? Nope. And y is greater than 3. So our graph is going to be y is less than -1 or y is greater than 3. So I'm going to write this down here at the bottom. Put our 0. So we have y is less than -1. So we have an open dot. And it's less than, so it's going to the left. Now we have our +3. And it's an open dot. And it's going to the right because it's greater than.